his organs disintegrate into a soupy liquid. Miraculously, after 1 to 2 weeks, a complex winged butterfly emerges. This metamorphosis takes place in a matter of days, not millions of years. The adult butterfly now has 6 segmented legs, antennae, a specialized feeding tube, 2 amazing compound eyes, complex reproductive organs, and 4 ornate wings. The caterpillar had none of these features. Clearly, the genetic instructions for all these stages were programmed into the insect by the creator from the beginning.
When a butterfly changes from a caterpillar to a chrysalis to a butterfly, there are 2 completely different designs here. One design is for the caterpillar, that's the initial stage, and all that does is creep around on the backside of a leaf, and it munches and eats all day, increases its size about 250 times. That's all it does. But then it goes into the chrysalis and turns into liquid, and then it comes out with a totally different design. What was the butterfly designed to do? Well, that was designed to fly, of course, but the caterpillar wasn't. It was designed to drink the nectar from the flowers, but at the same time fertilize the flowers. It was designed to mate, and it was designed to be able to migrate from one country to the other, several thousand miles in some cases. So it's designed for specific things. The caterpillar has one thing to do, to grow, eat and grow. And the butterfly has several things to do: eat, grow, fertilize, and mate.
That's another thing that Darwin talked about, that if there are, symbiosis aspect of things, you've got insects that are needed for pollination. The flowers didn't evolve a process to pollinate themselves. There were insects that had to do that. So there's another feature that blows a hole into Darwin's theory. By the way, I was just told that I can go until 8:30. Is that okay? All right. So, what's interesting about this, I'm not going to read all of this. I'm just going to summarize this slide, but you're probably reading it as I'm talking. That's okay. But basically, different butterfly species, there's not one particular mechanism where that biological mush inside the cocoon forms the body parts of the butterfly. Depending on the species of butterfly, there are slight nuances and differences in how this takes place. And that's, again, puzzling to evolutionists, because they think a process that's this complicated should have evolved only once and evolved to do it the same way every time. Why is it so varied? And it is. And yet, there's no way that Darwinian evolution can explain this metamorphosis. What I find interesting is that the word in the scriptures that's used about our resurrected body is the Greek word we get our word metamorphosis from. These bodies are going to be metamorphosized into resurrected bodies.
Yes.
Now, if I were to tell that to a little kid, they might think, do you mean we're going to become butterflies? So I only share that because my wife shared that with one of our kids one time about the Trinity or something.
The resurrection.
The resurrection.
I was teaching about the resurrection.
Yeah.
And they came up with, oh, they're going to be zombies.
Or something, yeah.
No.
So, but it was a teaching moment. So. Okay. Anyway. Now, here's another example of this, not so much a symbiotic relationship, but it just so happens that certain animals, certain creatures, can be camouflaged. But the way that the animals had to evolve to have their certain features had to evolve separately from that which they're camouflaged against. And again, Darwin himself in his book says that could not be the case. I mean, well, he said he couldn't find a case of that, but he says that it would basically destroy his theory, because you can't have two separate things, you know, they're so far apart, like a plant, a leaf, and this insect here. So you've got this insect called a walking stick, and it blends right into what it's walking on. And what's walking on had to have evolved, according to Darwin, separately. Well, what would make these two separate things evolve in such a way that later on, when algae evolution is finished, the insect would totally blend with what it's supposed to blend with? Again, this tells you that there had to be a designer from the very beginning to put this together. So insect camouflage is a very fascinating subject. There's another little tree hopper, poses as a thorn. Okay, that's a little insect that looks like the thorn on a rose bush. There's the orchid mantis. Okay, that's kind of hard to see. I don't have my laser pointer with me, but there's like the forearms right here, and the antennae, and the head right there, with the two eyes. That's an orchid. It looks like a mantis. Okay. Then you've got the dead leaf butterfly. It looks like a dead leaf, but on the inside the wings look like that. On the outside they look like a dead leaf. On the inside they're colorful.
When they're folded up like that.
Yeah. So why wouldn't they be colorful on both sides or brown on both sides? This is a stamp. This is a fingerprint of God saying this got designed. This did not evolve. So there's no self-consistent evolutionary process that can account for the existence of those designs. Okay. In other words, how would the evolving insect know ahead of time what it had to evolve into functionally in the features if trees and plants were presumably all evolving at a different time and a different rate?
Even if it had the power to evolve
Yes.
of itself.
Now, there's also the problem of vertebrate camouflage. We looked at insects. There's some Solomon Island leaf frog that's hidden in there. There's a whole bunch of them actually that are hidden in there.
How many were there? 5?
Something like that. You see the eyes here, there's eyes. Yeah. So, yeah, they're all hidden. And then there's an owl. There's a leaf-tailed gecko. His tail looks like a curled up, dried up leaf. I think God had a lot of fun when He designed things for our pleasure. Again, there's no coherent, self-consistent evolutionary process that can account for why these are designed this way, why they look this way, why it should be this way. Then there's fish camouflage, okay? As you know, fish have marking, colorings, appendages. Some of them make them appear larger, some of them make them look like they have eyes in the back, but they're bigger to maybe make another fish think it's a bigger fish that I'm coming across. And there's a striped one. Yeah, lionfish. And there's an example of a fish where the big black spot is on the back. Okay, these are actually pictures that my wife and I took when we were visiting the aquarium in Long Beach, the Long Beach aquarium. It's a leafy sea dragon. And there's a little video. This is a very short video that goes along with this as well.
Was that my video?
Yeah, that's your video. Yeah, so this thing is a seahorse, and it's got these appendages that look just like seaweed.
Yeah.
That's amazing.
It's
So totally amazing.
I've seen them.
Yeah. They're just floating along.
Looks like a dragon too.
Yeah.
Yeah, they call it, I think, the dragon, leafy dragon sea
Okay.
horse or something like that. Yeah, it's pretty amazing.
Looks like a plant.
Yeah, so how would it know the seaweed was going to look like as it was evolving? So, and then mollusks camouflage. Some marine life has the ability to adaptively change their camouflage. When I was working in the engineering field, adaptation was a very key design feature. Whatever you designed, you really wanted it to have the flexibility to adapt to different types of things. We have our eye, and the iris in our eye, we can adapt to varying degrees of light, from really bright sunlight to going to a darkened room, and if there's a little bit of light, our eyes adapt to it. We have a great dynamic range. We had a problem with the IR detectors that they were only designed for one particular dynamic range. They couldn't adapt, and we were trying to get them to adapt. So adaptation is very good, that you can adapt in real time to your environment. God had us beat by thousands of years, and an example of that I'm going to show you has to do with this.
Oh, yeah.
Yeah, the octopus. I call it marvels of marine life engineering. So,
Is this the cuttlefish too?
it's not the cuttlefish,
Wars of
but
the world are creatures more magnificent
this will also
than
be better
mankind
with
could
the
ever
light start
imagine.
and Bill. Thank you.
The enormous assortment of ocean dwellers speaks of the unlimited ingenuity of our great creator. And each sea creature has been designed with remarkable functionality. God equipped the octopus with a form of jet propulsion, suction cup technology, and self-adjusting camouflage far superior to any man-made design. Watch as this giant octopus morphs into a rock with algae. Its color, shape, and texture are all transformed in an instant.
There's a cuttlefish.
There's the cuttlefish.
Yeah.
The squid on the left is a male. He shows a brownish-red courtship pattern toward the female, while simultaneously showing a white fighting pattern on his opposite side to ward off rival males. As he switches sides, his markings actually flip. Dual simultaneous signaling demonstrates God's engineering supremacy. Underwater symbiotic relationships reveal perfect foresight in design planning. Sea anemones are poisonous, yet God has enabled certain fish to safely cohabitate in their environment. For example, clownfish are designed with an immunity to the anemone's poison. This could not have been inherited, as prior generations would have been killed and gone extinct before evolving a beneficial immunity.
Yep. But I'll tell you, that octopus is amazing because it was totally adaptive. And it can adapt to anything. That was just a rock that had algae on it. If there was another rock somewhere else that had a different shape or color to it, it would colorize itself and put itself in that shape.
Barnacles or something.
Yeah, it would do that too.
Checkerboard, man, it's really.
Oh yeah, the checkerboard, I've seen that, where they actually put a cuttlefish in a checkerboard bottom in a tank, and it changes itself to black and white squares.
Oh my
Yeah,
Yeah.
and it uses, in its layers of skin, it actually uses a similar process that they use in LCDs and LED, not LEDs, but LCDs, liquid crystal displays, where there are different layers, and then there are nerve connections to changing the shape and the color. So they can change the color, but also change the shape of their skin. It's amazing.
But they have to take the whole information.
So here's biomimicry. So I mentioned this earlier, and someone mentioned they hadn't heard of this term before, but basically biomimicry has to do with looking at things that are designed in nature. Oops, did I say design? And taking them and exploiting those designs for our benefit, for man's benefit. So here's one that was used to design one of Japan's bullet trains. Okay, so you've got this bird called the kingfisher, and it dives straight down into the water to get a fish. When it does this, it does so without any splash, or very little splash at all. It just totally streamlines into the water. And what they had a problem with these bullet trains, as you can see, they go 200 mile an hour plus. And again, I'm not going to read all of the print there. There's kind of a lot of it, but basically talk about this. What would happen is these bullet trains, they were going so fast, they were going through tunnels. They were going so fast, and the tunnels were so narrow, some of them, that the air in front of the bullet train would compress. So as the train was going through the tunnel, all this air was being compressed in front of it. So when it got out, exited, that compressed air was free to explode outward, and that's literally what it did. It caused sonic booms. It would rattle people's windows, it would break windows, it would upset the cows and their milk cycle, or the farmers in the area, and they were all up in arms, and they said, you've got to do something about these sonic booms of these bullet trains. Well, they looked at the kingfisher bill, and even the little